Okay, tape 68, we're going to talk about rational expressions. On this tape we'll do multiplication and division. Of course the first one will be reducing it, but we'll set up the concept of multiplying, dividing rational expressions. All right, so let's look at example 1. First thing, always look for a common factor. Always look for a common factor. If you have a fraction, if you have multiplication, division, complicated expression or something, look first to see if you can find a common factor, and we do in this case. A common factor in the numerator is a 5, so we'll take a 5 out of that. All right, now I'll check it. If I multiply this times that, that checks. This times that, that checks. All right, divided by. All right, now listen closely to this. You don't just mark out letters and numbers. You're saying this. What will divide into this denominator that will divide in all of this numerator? And the answer is 5. So if I divide 5 into 5, it goes one time. And if I divide 5 into 5, it goes one time. I am not canceling out or marking out the 5s. I'm dividing here and dividing here. Now what I have left is 1 times that, which is p minus 2, and I have over 1. So you could leave your answer like this. You could leave your answer without the parentheses. Either answer is correct. So we're going to look for a common factor, divide it out, and then see if you can reduce the fraction. All right, let's look at example 2. Now, in example 2, here's something else that you need to listen closely to. When you have binomials, 2 terms, binomials, put them in parentheses. And you don't divide out this 2 and that 2 and this x and cancel. You have a parenthesis. You have to find a parenthesis just like that on the bottom. That's not just like it. But we can change it. X plus 2 and 2 plus x are the same thing. We can switch these as long as that is addition. If that's subtraction, you can't do it. In the example next one will show you. But we can switch those. Now I have a parenthesis that's the same. So the parenthesis will divide in that one time, into that one time. Our answer is 1 over 1, which is 1. All right, let's look at example 3. Now in example 3, here's the case of the subtraction. And the first thing I'm going to do is put them in parentheses. All right. Now the next thing, I'm going to have to try to get them to look like the same parentheses. So what I'm going to do is factor a minus out of the top one. And that will change it. So here's the one you need to look at this. You need to see that if I need to switch those, then what I do is factor a minus 1 out. Okay? Because now when I multiply back in, this times that is the minus x, and this times this is the plus 2. So to switch 2 that have a minus sign between them, then factor out a minus. Now this parenthesis is the same as that, so I'll divide this into that. It goes one time. Into this one time. Final answer is a minus 1. All right, let's look at example 4. Now, example 1, what was our statement? Always look for a common factor. Always look for a common factor. So on the top, we have a factor of x. So we factor it out. Right. So this multiplied back in, checks, did it right. Now the bottom, common factor, no. But now look to factor into 2 parentheses by the FOIL method. Factor into 2 parentheses by the FOIL method. Now, do we have anything that's the same? No. So therefore this problem is simplified as far as it can go. Okay. Now, if this had been a 2 up here, okay, then look what would have happened. All right, so I'm going to change it now to a 2. And let's look at the problem to start all over. Common factor. Yeah. Bottom one, common factor. No. Therefore, look to factor it in 2 parentheses. Yes. Now, these will now divide out, 1 and 1. And what we have left is x over x plus 2. Now, listen, 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 and watch this. When you have this in parentheses, you should see that this cannot be reduced any further. Okay? Whereas too many students, at times, carelessness, written this way, they'll mark the x's out. So if you'll keep binomials in parentheses, and the only thing you can divide out then is another parenthesis just like that one. Okay? Now let's look at example 5. Example 5, we're going to put several of these other examples into the problem. So let's take now common factor. No. Factor in 2 parentheses. Yes. A minus B and A plus B. The bottom one, put in parentheses. Any of those the same? Any parentheses the same? No. But I can switch this one and make it like that one. So I'll rewrite the top one. And you could do the top one, change it. It doesn't make any difference. And I'll factor a minus out of the bottom one. And so now these divide out, 1 and 1. And we have left A plus B in parentheses over minus 1. Or 1 goes into that, A plus B, and a minus out in front. Now, that's the final answer on this. In the back of the book, you might see a minus A minus B. This is okay. This is just as good as minus A minus B. And that's what you need to know, that your answer, as long as it's the same answer, but maybe a different form, your answer is still okay. So in this problem we put together where you have to use the minus to switch them, the concept of factoring, and so now let's continue with that, with the idea of factoring. So looking at example 6, this one is, no, don't you dare go through here and divide stuff like this. What you have to have is into parentheses. Now, before you can divide things out across the division sign, it must be all multiplication and or division. It must be all multiplication. Parentheses times, parentheses, divided by parentheses times, parentheses. Everything in here is multiplication division. Not up here. You have addition and subtraction. So you do not divide out unless it's all multiplication and division. All right, let's factor the top one. 2A and A. And what would we put? A minus 3 here and a minus 2 there. And that doesn't work. Okay, so let's go switch these. So if we put a minus 2 here and a minus 3 there, works. That's how you factor. First times the first, last times the last, inside, outside. And you just switch these numbers around till it works where that middle term works out correctly. So now let's take the next one, the bottom one. So we have 2A and A, and we have 3 and 2, and again that doesn't work. So let's try 2 and 3 this way. Now that's not looking too bad because this is 4 and that's 3. And I want a 1 here, so I'll make this the positive and this the negative. And so now it checks. Now, we get to divide those out. So we have 1 times a minus 2 over 1 times a plus 2. And that's the final answer, okay? Because this parenthesis is not like that parenthesis. So learn to put binomial. Okay, looking at number 7. Okay, first thing we need to do is to look for common factor. No. Next thing, put that in parentheses. Bottom one, common factor. No. See if we can factor into 2 parentheses. So that'll be 2x and x and minus 5y and plus y. And first times the first, yes. Last, yes. Inside, checks. All right, times. Common factor? No. 2 parentheses? Yes. X minus 5y and x plus 5y. Bottom one, common factor? Yes. Let's see. What will divide of the numbers? 3. What letter's common to both of these? X. So it leaves us 2x minus 3y. Now then, we have it all factored, and we have multiplication. So let's look at that. If I have 10 over 15 times 9 over 27, now let's say 28, excuse me. Then what would we do? Let's see, 2 will go into that, 2 will go into that, 3 will go into this, 3 will go into that. So we go through that process. Well, we do the same thing then with this. So what's down here is the same, well, that parenthesis is the same as that parenthesis, so we divide those out. And let's see, this parenthesis is the same as that parenthesis, so we divide those out. Now what do we have left? That doesn't divide out. So now listen and watch. We now have this times this times this. So it's the top times the top over the bottom times the bottom. So this times 1 is x plus 5y. And this times this is 3x and 2x plus y. And that's our final answer. We have those in parentheses, and if those parentheses aren't the same, we leave them alone. So you can leave your answer that way, or you can multiply and remove parentheses. Either answer is sufficient. Okay, let's look at a couple other examples now. Okay, looking at example 8. What's our first step? Look for a common factor. Common factor is x squared. So it leaves us x plus 1. No common factor here, just leave it alone. Now, here's our new rule. When you divide, you invert and multiply what's behind the division sign, what is directly to the right of the division sign. So we're going to invert and multiply. Okay, still look. Common factor, factor, division, invert, and multiply. So now we look to see what will divide out. Well, let's see. This x squared will divide out with this x squared, or this one. It doesn't make it, when you have all multiplication and or division in a problem, you can divide out here or across over here. Okay, so it doesn't make any difference. So we'll divide that in that one time, into that one time. 2 will go into 4 2 times. 2 will go into this 13 times. All right, so looks like that's all we have. So what we have left is 13 times x plus 1 over 2 times 1 times that over 2x squared. All right, and so that's what we have as a final answer. And again, if you some students without the parentheses would mark out this x with this x. Don't do that. Okay, be careful. All right, example 9. All right, let's see. This one's already factored into a power, so we'll copy it down. Now, what's our rule? Our rule is, well, wait a minute. Our rule was to factor. So let's factor this into a minus 6 and a plus 3. Check it. First times the first? Yeah. Yes. Middle term? No. This would give us a minus 3a. So we need a plus and a minus 3. So the first step is to factor. Now, some of you have done this before, and you may do all this in one step, but still, stay with our rule. Common factor, factor. Now use the rule, when you have division, you invert and multiply. All right, now when we have all multiplication division, then we can divide. Right? Well, 7 will go into 7 one times, 14 two times. What you need to do now is look at this parenthesis as a single object. We have one of these and we have 3 of these. Just like if we had x cubed over x, we would divide out and have x squared. So this divides into this and leaves us squared. So now, multiply the top times the top. 1 times this would be a minus 3 squared over 2 times this. 2 times a plus 6. All right? So we leave it just like that. All right, let's look at another example. This is not in the notes, but let's look at it and talk about this. All right, so the first thing to do is look for common factor. No, factor in the parentheses, if it will. So this will go x minus 4 and x plus 1. This will go x minus 1 and x plus 1. Okay. Put it in parentheses. Put the binomial in parentheses. And this will factor into x minus 4 and x minus 4. All right, now our rule is to do the division. Okay, so we look for the factors the same. Well, right there in the same part, just like over here in the same part. All right, so what we have left is x minus 4 times x minus 4, so that's x squared, over x minus 1. Okay, this should be sufficient to get you the steps necessary for you to work the problems on rational expressions. Number 1, common factor. Number 2, factor trinomials or perfect squares, the difference of perfect squares. Get all that factored, and our rule is if you have multiplication, just multiply the top times the top, bottom times the bottom. Divide out what can be divided. If you have division, you invert and multiply.